Hello everyone, this is Dr. Kalpana and you're watching my YouTube channel Pharmacy Lessons Made Easy. The topic for this video is solubility. So the solubility will be discussed in terms of the terminologies that are used for pharmacy, the meaning of solubility in pharmacy profession, different categories and the limit of solvent that is used to solubilize any active pharmaceutical ingredient, and the practical significance of determining solubility thereof. So let's begin. First we should understand the basics of solutions. The solution is exactly a mixture of two or more components that form a homogeneous mixture. The components are referred to as solutes and solvent. The unsaturated solution is also known as subsaturated solution. It is one which contains the dissolved solute in a concentration below which is necessary for complete saturation at a defined temperature. A saturated solution is one in which equilibrium is established between the dissolved and undissolved solute at a defined temperature. It is also defined as a solution which contains maximum amount of solute at a defined temperature. Now how do you define solvent? Solvent is that component in which the solute is dissolved and it is more abundant part of the solution. The solute is the dissolved agent, that it is less abundant part. Okay, let's move to our next part, that is how you quantitatively define solubility. Solubility, if we talk about quantitative definition, it is a concentration of solute in a saturated solution at a certain temperature. Why temperature is mentioned here? Because the temperature affects the solubility of any substance. That's why we try to find the value of solubility at particular temperature of it. Moving forward to the qualitative definition, it is the spontaneous interaction of two or more substances, that means a solute and solvent of course, which are to be mixed so as to form the solution, to form a homogeneous molecular dispersion. So this is the qualitative definition of solubility. So the next thing is the expression. Before moving forward to the expression, I shall summarize the solubility definition. In a nutshell, solubility is the property of a solid, liquid or gaseous chemical substances which are called solute to dissolve in a solid, liquid or gaseous solvent to form a homogeneous solution of the solute in the solvent. The solubility of a substance fundamentally depends on the solvent used as well as the temperature and pressure. The extent of solubility of a substance in a specified solvent is measured as the saturation concentration, where adding more solute does not increase its concentration in the solution. Now is expression. The extensive use of solubility from different perspectives had led to solubility being expressed in various manners. It is commonly expressed as concentration either by mass, for example gram of solute per kg of the solvent, or gram per deciliter or 100 ml of the solvent. Other expressions are molarity, molality, mole fraction or other similar descriptions of the concentration. The maximum equilibrium amount of solute that can be dissolved per amount of solvent is the solubility of that solute in that solvent under the specified conditions. Now this is a special case. The saturated solution of ionic compounds which have relatively low solubility, they are sometimes described by the term solubility constant. Moving to the next part, the USP and BP, that is United States Pharmacopoeia and British Pharmacopoeia, classifies the solubility regardless of the solvent used, just only in terms of quantification, and have defined the criteria as shown in the table here. Here the different categories of substances are displayed as per their solubility, that is a part of solvent required for getting dissolved per part or per one part of it. The extent of solubility ranges from very soluble to practically insoluble. In case of very soluble, the part of solvent required for solubilizing one part of solute is less than one part. What does it mean? It means that 1 gram of a very soluble substance will dissolve in less than 1 ml of the solvent, that is 1 gram per ml. Moving to the next part, that is freely soluble, it required 1 to 10 part of the solvent for solubilizing one part of solute. In the similar way, the soluble components will define it as soluble if the part of solvents required are from 10 to 30 parts for one part of solute. Similarly, sparingly soluble will require 30 to 100 parts. Slightly soluble components will require from 100 to 1000 parts. Very slightly soluble will require from 1000 to 10,000 parts, and practically insoluble will require more than 10,000 parts. So you can easily learn this table by, and the category especially, how you classify the substances on the basis of your solubility. What quantity of solvent you exactly require for dissolving one part of solute, that is the criteria to describe that component as either very soluble or freely soluble, or soluble, sparingly soluble, slightly soluble, very slightly soluble, or practically insoluble. Now let's learn the concept of miscibility term. Miscible means the substance which yield a homogeneous mixture when mixed in any proportion with a designated solvent. So here the proportion as well as the solvent both are important, right? So if that mixture yields a homogeneous one, if they are mixed in any proportion, for example, if we take ethanol and water, so if we mix them, then the mixture that we obtain is homogeneous in nature, and it doesn't depend on the proportion that we have taken. So in any proportion they both are miscible with each other. One important feature is very interesting. Actually, the solubility is based on highest dose strength of an immediate release product. A drug is considered highly soluble when the highest dose strength is soluble in 250 ml or less of aqueous media over the range of 1 to 7.5 pH. So the volume estimate of 250 ml, from where it is derived? It is derived from typical bioequivalence study protocol, which prescribes the administration of a drug product to fasting human volunteers with a glass of water. Moving forward to its application part, the solubility is a very important parameter to achieve the desired concentration of drug in systemic circulation for desired or anticipated pharmacological response. Actually, low aqueous solubility is the major problem encountered with formulation development of new chemical entities as well as for the generic development. It has been observed that more than 40% of new chemical entities developed in the pharmaceutical industry are practically insoluble in water. Solubility is a major challenge for formulation scientists. Any drug to be absorbed must be present in the form of solution at the site of absorption. Various techniques have been utilized for enhancement of solubility of poorly soluble drugs, which include physical and chemical modification of the drug and other methods like particle size reduction, crystal engineering, salt formation, solid dispersion, use of surfactant, complexation, and so on. So the selection of solubility improving method, that will depend on the drug property, the site of absorption, and the required dosage form characteristics. Now, what is the importance of learning the solubility? So understanding the phenomena of solubility will help any pharmacist to select the best solvent for a drug or mixture of drugs. It will overcome the problems which arise during preparation of pharmaceutical solutions. It will give the information about the structure and intermolecular forces of the drugs. Many drugs are formulated as solution or added as powder or solution forms to the liquids. The drug with low aqueous solubility often present problem related to their formulation and bioavailability. So if we have an idea of the solubility of that particular drug, we can arrange some method for modification of the parent drug or selection of solvent, and so many methods are there to improvise the solubility problems. I hope you people like this video. These are a few references. Please click on the like button, subscribe my channel and share it on social media. Thank you very much.